So the next topic is electric dipole. अब इलेक्ट्रिक डाइपोल होता क्या है? सो कभी भी दो चार्ज पार्टिकल को अगर आप एक पर्टिकुलर डिस्टेंस पे रख देते हो, लेट्स से, और वो डिस्टेंस को हमने नाम डिस्टेंस दे देते हैं 2a यूनिट्स. So this system of two equal and opposite charged particles placed at a certain distance apart is an electric dipole. Intentionally यहाँ पे दोनों का जो डिस्टेंस है वो 2a लिया जाता है ताकि जब हम उसको डिवाइड करें तो एग्जैक्टली सिमेट्रिकल पॉइंट ए के डिस्टेंस पे सेट हो. ठीक है. So this system is known as the electric dipole. It is characterized by a unit which is known as dipole moment. और dipole moment को हम define करते हैं. First of all, the symbol is P, and it is defined, the magnitude of the dipole moment is defined by the magnitude of the charge into distance between the charges. Okay, so it turns out to be 2qa, and the unit is, as you can see, Q stands for Coulomb and this is meter, so Coulomb into meter. Now, what does this dipole moment signifies? It signifies the strength of the system, the weakness and the strongness of the system. It gives a subjective, or you can say a quantitative aspect to the given system. Because it's a vector quantity, the direction of the vector is from the negative charge towards the positive charge always. Okay, so this is your dipole moment vector. It is generally symbolized by using a unit vector, that is p cap, which signifies the dipole moment vector from negative charge to the positive charge. जब आप डायपोल मोमेंट कैलकुलेट करो तो एक चीज़ ध्यान रखना, जो चार्ज वैल्यू है वो सिर्फ मैग्नीट्यूड में लेना है, बिकॉज इट्स एन इक्वल एंड अपोजिट चार्जेस. यू कैन टेक द वैल्यू ऑफ ईदर ऑफ द चार्ज, जस्ट डोंट यूज अ नेगेटिव साइन. एंड यहाँ पे 2a लिखा हुआ है और 2a स्टैंड्स फॉर डिस्टेंस बिटवीन द टू चार्जेस. Okay, so for example, if you're given the distance between the two charges as 5 micrometers, substitute the value of 2a as 5 micrometers only. ठीक है, don't substitute 2a equals to 5 and don't substitute a equals to 5. Okay, this is a common mistake that students do if you're not clear with the formula itself. तो याद रखना कि अगर distance between the charges कोई भी x वैल्यू है, लेट्स से यहाँ पे मैंने 5 माइक्रोमीटर ली थी, तो दैट इज द वैल्यू ऑफ 2a इक्वल्स टू 5 एंड नॉट a एज 5. ओके, सो दिस इज सिंपल डाइपोल एंड कैरेक्टराइज्ड by a quantity known as dipole moment. Just write the direction from negative to positive charge always. Two important concept after the studying the introduction of dipole, that is electric field due to dipole. So अगर कोई भी एक डाइपोल लिया जाए, plus q minus q, so this line passing through the midpoint and perpendicular to the axis. First of all, the axis is the line passing through both the charges, is the axis of the dipole. Okay, line through both charges. अब उस लाइन के परपेंडिकुलर जो लाइन होती है जो मिड पॉइंट से पास करे, दैट इज योर इक्वेटोरियल लाइन. So we'll first calculate the electric field on the axis and the equatorial line. So first, axis of the dipole, center of the dipole, this is your plus q charge, minus q charge. A point P is located on the axis at a distance r from the center. From either charges, the distance will be this distance will be r minus a, and this distance will be r plus a. We won't go into the derivation perspective, just remember the formula directly. So the magnitude of the field at point P is given by 2kp upon r square minus a square whole square. This is a general formula. We'll have the special case in a minute. Okay. And if your R is much greater than A, example, your A is in the order of millimeters and R is in the order of multi-centimeters, you can use the spatial case, that is electric field at a point P. The magnitude is just 2 kp upon R cube. Okay, so the two formulas gives the magnitude of the electric field at a point P for a dipole system on the axis at a distance R. Okay, so direction की अगर हम बात करें, it is always in the direction of dipole vector. सिंपल शब्दों में हमेशा इलेक्ट्रिक फील्ड नेगेटिव टू पॉजिटिव चार्ज होगी on the axis of the dipole. It doesn't matter whether it is a general, whether you are using a general formula or the special case. मतलब डिस्टेंस जो भी हो, बहुत छोटा हो बहुत बड़ा हो, r की वैल्यू हमेशा डायरेक्शन नेगेटिव टू पॉजिटिव ही रहेगी. Okay, so the direction is always given by this formula. Okay. Now, the second case is equatorial line. Okay. So this is the axis of the dipole. The equatorial line plus q charge minus q charge, a given point P, a distance, this is your r distance. Okay, this is your the direction of dipole moment vector. So electric field at a point P for a general case is given by kp upon r square r square plus a square whole raised to 3 by 2. And for much greater distance, that is r much greater than a, सेम लॉजिक जो हमने ऊपर वाले सिस्टम में देखा, उस केस में इलेक्ट्रिक फील्ड जस्ट रिड्यूसेस टू, द मैग्नीट्यूड रिड्यूसेस टू kp अपॉन r क्यूब. सो एंड जहाँ तक डायरेक्शन की बात है, डायरेक्शन इज ऑलवेज exactly opposite of the dipole vector. Opposite of dipole vector. That is, dipole vector negative to positive होता है. Okay, so ये जो एक सेकेंड, so this is our distance. So dipole moment का जो वेक्टर होता है वो नेगेटिव टू पॉजिटिव रहता है. तो ये हमेशा उससे अपोजिट डायरेक्शन में ही रहेगी इलेक्ट्रिक फील्ड, दैट इज एट दिस पॉइंट. ओके, सो अगर आप रेशियो लो एक्सेस टू इक्वेटोरियल का, फॉर आर मच ग्रेटर देन ए, और अगर सिर्फ मैग्नीट्यूड की बात की जाए, so it is 2:1, and if you are including the direction as well, that is you're taking the ratio of the vector quantities, then the answer will be -2:1, because in magnitude form you need to include minus sign here. Okay. That is opposite to dipole moment vector. Now ये दो तो सिर्फ हमारे जनरलाइज केस थे कि अगर एक्सिस पे हो, this formula is for axis and this formula was for equatorial line. What if there's a general point in addition other than the axis and the equatorial line? Although ये वाला जो टॉपिक है वो फॉर्मूला एनसीईआरटी में मेंशन नहीं है, but still it is easy to remember the formula without the derivation part. This is your equatorial line, this is your axis, plus q charge minus q charge. So the dipole moment vector is from negative to positive. This is your dipole moment vector. So let the point be somewhere here. So this is your r vector, that is the position vector of the dipole from the origin. This point is taken as the origin, the midpoint of the dipole. Let this angle be theta, that is theta is angle between dipole moment vector and position vector of a given point. So the electric field at a point P is equal to Kp by r cube into under root of 1 plus 3 cos square theta. This is the magnitude, okay, just the value part. यहाँ से आपको वैल्यू मिल जाएगी इलेक्ट्रिक फील्ड की. और डायरेक्शन की बात है, अगर मुझे वेक्टर फॉर्म में लिखना हो या सीधी डायरेक्शन लिखनी हो, सो इट इज in the direction of dipole moment vector. Okay. Oh, sorry. I think I said in the direction of dipole moment vector. It is wrong. It is in the direction of the position vector. That is यहाँ पे r cap लगेगा. Okay. Now, अगर किसी भी डाइपोल को एक्सटर्नल फील्ड में रखा जाए, what does happens in the dipole? So it depends whether the field is uniform or the field is non-uniform. So if the field is uniform, uniform field is there's a dipole placed at an angle theta with the position, with the electric field direction. So this is your dipole moment from negative P to positive P. This is your dipole moment direction placed at an angle theta. So अगर हम इसका FBD बनाएं तो Q चार्ज यहाँ पे है, उसके ऊपर QE फोर्स राइट साइड लग रहा होगा, माइनस Q समवेयर यहाँ पे है, सो उसके ऊपर जो QE फोर्स है वो लेफ्ट साइड लग रहा होगा. एज यू कैन सी इक्वल एंड अपोजिट बट नॉन कोलिनियर. इक्वल एंड अपोजिट फोर्सेस लग रहे हैं सिस्टम पे बट दे आर नॉन कोलिनियर. सो नॉन कोलिनियर इक्वल एंड अपोजिट फोर्सेस, they do cancel each other but they also generate a torque. So here the net force becomes zero on the system, but because they are non-collinear forces, they generate a torque which is given by the magnitude of the torque is given by Pe sin theta, where P is the dipole moment magnitude, E is electric field magnitude, and theta is the angle between electric field and the dipole moment vector. And in the vector form, it is given by P cross E. Okay. Now what happens if the field is not uniform? Okay, so if the field is not uniform, then obviously the net force won't be zero. So if there is an electric field in this direction, oh sorry, I have represented a uniform field. Mistake. Yeah. So let the field be non-uniform. And and if in this field dipole is placed, in that case the magnitude of the force on the positive charge and the magnitude of the force on the negative charge won't be equal. From the figure, the plus charge feels more force or experiences more force than the negative charge because the field lines are more close towards the positive charge. So closer the field lines, stronger the magnitude of the electric field, and hence stronger the force. So they won't be equal, and so the net force is not zero. But जहाँ तक टॉर्क की बात है, the torque may or may not be zero. सो यहाँ पर सारी थियरी हो गई इलेक्ट्रिक डाइपोल की. नेक्स्ट पार्ट में हम गॉस लॉ पे फ्लक्स एंड देन गॉस लॉ को डील करेंगे या गॉस लॉ को समझेंगे.